If you do not measure retrieval, you are guessing. Generate a small evaluation set and score it. You are staring at broken answers or flaky citations, and you do not know if the retriever or the reader is to blame. In 10 minutes, you will build a tiny, repeatable RAG evaluation that shows both retrieval hit rate and simple grounding coverage. You will get a single baseline number you can compare across experiments and a clear place to iterate. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced with simple concepts-first Python that helps you solve bigger real-world problems. Retrieval augmented generation helps when your model needs external facts. The usual pain is you cannot tell whether a bad answer came from the wrong source or from hallucination. A quick synthetic evaluation answers that question. Success looks like a reliable hit rate and a coverage metric that together tell you whether your retriever finds the right docs and whether the answers actually draw from those docs. At a high level, we will make a tiny controlled corpus, derive simple question-answer pairs from it, run a naive term overlap retriever, and then measure two ideas. Hit rate at top K tells us whether the right document is in the candidate list. Coverage measures how much of the answer comes from the cited document. Both are easy to compute and easy to interpret. We will use a tiny deterministic toy corpus, so results are repeatable. This keeps experiments focused and fast. Now, we will seed that corpus. This snippet seeds a tiny deterministic corpus for RAG evals. It fixes a random scene to keep any later sampling stable across runs. The variable docs is a small dictionary mapping IDs to short texts that mention core retrieval ideas. Keeping IDs small and texts compact makes later ranking and metrics easy to read. With this minimal setup, we have a controlled environment to iterate on retrieval and evaluation without external files or services. The printed count confirms the corpus is ready and repeatable for experiments. Next, we will build a tiny synthetic QA set from those documents. This snippet builds a small synthetic QA set from the mock docs. It defines talk, a lightweight cleaner and tokenizer using a regular expression to strip punctuation. For each document value, it forms a query by taking the final token as a simple P phrase and templates it into a question. The list QAS holds pairs of question text and the ground truth document ID used later for scoring. Sorting by document ID keeps the ordering deterministic, so comparisons across runs are fair. The printed count shows how many QA pairs were generated. Now we compute a basic retriever metric, hit rate at top K. This snippet computes retrieval hit rate at top K using term overlap. For each Q and ground truth ID in KIS, it scores every document by counting how many tokens intersect with the query tokens. It sorts the scores descending, slices the top K, and checks whether the ground truth ID is present. The variable HR accumulates correct hits. Then the print formats the fraction as a 2-decimal rate. Increasing K generally improves hit rate, but adds latency. Decreasing K tightens precision, but may miss relevant docs. A high hit rate means your retriever surfaces the right sources. Next, we simulate generated answers and see how much they cite the retrieved source. This snippet simulates answers and measures citation coverage. It retrieves the top document for each query, then builds ANDs from the first few tokens of that document, and adds a small amount of noise tokens. The set cited contains tokens from the cited source, and coverage is the fraction of answer tokens that appear in that cited set. The list cov collects per question coverage and the print reports the mean. Increasing the number of noise tokens decreases coverage. Reducing noise increases it. Coverage shows how much of the answer is grounded in cited context. Now, we will remove the artificial noise and combine the metrics into a simple baseline score. This snippet removes noise and combines metrics into a tiny baseline score. It picks the top document per query, forms an answer only from its tokens, and computes citation coverage again, which should rise without noise. The variable C-sum accumulates coverage across questions. Then score averages hit rate from earlier and the new coverage to create a single, simple run metric. With no extra tokens, coverage tends to 1.00, lifting the baseline. This printed baseline summarizes retrieval quality and grounding in one number you can compare between runs. Recap in 3 crisp points. What it is: a tiny, synthetic RAG evaluation that measures top K retrieval hit rate and citation coverage. When to use it: when you need a quick, repeatable baseline to tell retriever problems from generation problems. One caveat: the toy setup is deterministic and small, so it does not capture real-world text diversity or noisy user queries. Next step: scale this exact experiment by swapping the overlap retriever for an ANN index, or by tuning the top K parameter and then measure how hit rate and coverage change. That single comparison will tell you whether to invest in a better index or in more grounding controls. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.